Good morning, everyone. Today we discuss about the column basis. Generally, the entire load coming from the structure bear by the columns. In concrete structure, the column and soil have the footing is in between there. Here, the concrete pedestal. So, concrete foundation nothing but concrete pedestal. So, in between the concrete pedestal and column have a small structure that is slab base or column base or gazetted base. Column base transmits the load from column to the concrete foundation. The column base distributes the load on long range so that the intensity of bearing pressure on concrete foundation does not exceed the bearing strength of the soil. So next one, design procedure for column base according to IS 800 2007. It contains four steps. First one is size of the column base. Second one is thickness of the column base. Third one is dimensions of the concrete pedestal. Fourth one is connections. So in that, size of the column base has four steps in that. First one is factor load. So in your question, they give that working load or axial load. So we convert factor load with the help of the partial safety factor, that is 1.5. If he given the directly factor load, the first point we cannot perform. Second one, bearing strength of the concrete, that is the 0.45 FCK. Here FCK nothing but characteristic strength of the concrete or compressive strength of the concrete. Next one is area of the base plate required equal to factor load by bearing strength of the concrete. So fourth step is size of the column base. So column may be in square shape or rectangular shape based upon your need. Next one, second step, in thickness of the base plate. So we can see the class number 7.4.3.1 of IS 800 2007. Class number 7.4.3. 7.4.3, yeah, here you can see the minimum thickness nothing but T suffix x of rectangular slab bases supporting columns under axial compression shall be T suffix s equal to 2.5 W a square minus 0.3 b square gamma m naught by Fi. It should be greater than T suffix f, nothing but thickness of the flange. So if the value does not exceed T suffix f, you can use the thickness of the base plate equal to thickness of the flange. W nothing but uniform pressure from below on the slab base under the factor load axial compression. A, B are larger and smaller projections respectively of the slab base beyond the rectangular TF nothing but flange thickness of compression member. You can see that how the section in column can be placed in the slab base. Next, coming to that, W nothing but intensity of pressure. How can you get that? Use a formula, that is a factor load by area of the base plate. We know the dimensions of the base plate. Before the step also we calculated. Next one is third step, dimensions of the concrete pedestal. So here as also divided into four steps. First one is total load acting on the pedestal, nothing but concrete foundation, equal to axial load or working load, then P nothing but axial load or working load plus self weight of the pedestal. So next one, self weight of the pedestal nothing but 15 to 20% of axial load. Next, area of the concrete pedestal nothing but total load by soil bearing capacity. Next, third one, size of the concrete pedestal, so it should be rectangular or square. Okay, next, depth of the concrete pedestal, so nothing but B minus bs by 2, bp nothing but breadth of the concrete pedestal minus breadth of the column base by 2, that gives the depth of the concrete pedestal. Next, fourth step, connections. So connection should be in slab base, it is a fillet wall most of that, or a bolting connection, that is anchor bolt. So coming to the question, design a slab base, he has a slab base, column base or gazetted base, anyone. The procedure should be same. For a column section, ISHB 350 carries an axial load of 1500 kN, nothing but 1500 kN. The permissible yield stress on steel 250 Newton per mm square. Soil bearing capacity of soil, safe bearing capacity of soil 200 kN per meter square. M20 grade of concrete used in this question. If any missing data we can assume. So first of all we can write the given data, that is the axial load, safe bearing capacity, Fi, FCK are given in the question. Next, take the section ISHB 300, go to the steel table as well as code book, anyone, you can select anyone. So I am taking as a steel table. So here see the ISHB 300, ISHB 300. So we can write the required properties, nothing but sectional area, width of the flange, thickness of the flange, thickness of the web. Okay, next whatever the values required you can write. So next, start the procedure whatever be discussed above. Size of the column base, okay, factor load, he given the working load, it is converted into factor load. Next, bearing strength, so we know the FCK value, we got the bearing strength. Area of the base plate, we know the formula, so we can get the area of the base plate. So if you, it is I am taking as it is a rectangular shape, most probably column bases should be rectangular shape. In some conditions it is square, so I am considered as a rectangular shape. So in that, proposing that if you take the rectangular shape, so you know the length and breadth, only you know the area, so we can take some ratio. So that ratio should be within the limit. So okay, here length equal to h nothing but depth of the section by breadth of the flange into breadth of the base plate. So we got finally 1.4 b. So we can substitute in L place 1.4 b. We get the breadth of the column base, nothing but 422.57, it is nearly 430. Next we can find the length, so that is the size of the column base. Okay, so we can see in the figure here also. So same structure we can draw, we can find the smaller projections and longer projections, because we can find the thickness of the base plate. So here nothing but L minus h by 2, L nothing but length of the base plate, h nothing but depth of the section. So depth of the section according to our steel table 350 mm, so 604 nothing but length of the base plate, we can get the A value 86 mm. Similarly B also 90 mm. Next, step 2, thickness of the base plate. So intensity of the pressure nothing but total factor load by area of the base plate. Okay, so we can get 8.69 pressure. Next, T suffix s, you can see the code book. 7.4.3.1 here has one formula. We can substitute the total values in that formula. We get the thickness of the base plate, so it should be greater than thickness of the flange. If it is less than thickness of the flange, we can take the thickness of the base plate value, thickness of the flange value. So here 21.78 mm we got, so nearly 22. So thickness of the flange is 11.6, so it is correct. Next, step 3, dimensions of the concrete pedestal. So we know the formulas. We can substitute the both formulas above discussed in procedure. We can get the dimensions of the concrete pedestal. So we can find the next depth of the concrete pedestal, nothing but formula has breadth of the concrete pedestal minus breadth of the slab base by 2. We can get 1.25 meters. So total dimensions of concrete pedestal is 2.93 into 2.93 into 1.25. Next, take as a connection. So I am using the welding connection. So welding connection we can get, we know that already discussed in first unit, how can you weld and fillet weld or butt weld or slot weld. Okay, so if you, it is a fixed value for the steel 410 newton per mm square. So here taking as the 8 mm size of the weld. Okay, next you can find the fwd, fu by root 3 into gamma mw, we know the value. So we can find that next length of the weld. So this is the connections between column base to concrete pedestal. I hope that we understand. If you have any doubts, please ask. 11:30 to 12:30 for Monday, Wednesday, Friday. These 3 days we have the 3 classes. The timing is 11:30 to 12:30. If you have any doubts, you can ask in between that time by through phone call or WhatsApp group. Thank you.